Okay, in addition to using the bivariate probability distribution to find the probability distributions of X and Y, their covariance, their coefficient of correlation, and other parameters of the individual variables, the bivariate probability distribution can be used to develop a probability distribution of a third variable that derives from these two variables X and Y. This is very, very important property. In many cases, we are interested in the sum of two variables. So let's see what do we mean by that. How can we derive the probability distribution of a new variable, which is the sum of X and Y? Okay, so let's go back to our Xavier and Yvette's example, where we were given already their bivariate probability distribution. And we are interested in a variable Z, you can call it anything you want, which is what? It's the sum of X and Y. Okay, so you can see that this is a completely new variable, right? It's not X, it's not Y, it's X plus Y. So for any variable, we have already learned that it helps a lot to have its probability distribution. So, and the probability distribution has two columns. The first one is the possible values of that variable, and the second column is what's the associated probability of each value. So first, let's start with that. Let's list the possible values of Z or X plus Y. What do you think? What are the possible values of X plus Y? We can tell that from the bivariate probability distribution, because we can see here that X can take the value of 0, 1, or 2, and Y can take the values 0, 1, and 2. They are not necessarily need to have the same values, by the way, right? We can have here 0, 1, 2, and here we can have 2, 3, 4, whatever. So, but what's important now is to tell what are the possible values of X plus Y. How to do that? That's easy. For X equals 0, all right? What are the possible values of Y? What do we have? We have 0, we have 1, and we have 2, which means what are the possible values of X plus Y? Okay, it's 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 2 is 2. So we know so far that X plus Y can take the three values. What else? Again, here what you do, let me erase that so that I don't take much all right, space. And for X equal to 1, again, Y, these are the possible values. Now, what about X plus Y? It's 1 and 2 and 3. So far we have now 0, 1, 2, and 3. And finally, we have we have the value of X can be equal to 2, and for these values of Y, X plus Y then becomes 2 or 3 and 4. So what can we conclude? That X plus Y can take the values of 0, 1, 2, 3, and 4. Now let's find the corresponding probabilities, in which case X plus Y will be equal to 0. How many cases do we have? If you look back into the bivariate probability distribution, we can see that there's only one combination of X and Y that make X plus Y 0, which is this one, 0 and 0. And what the probability of this combination? It's 0.12. So here we go. The probability that X plus Y is 0 is 0.12. Now, what's the probability that X plus Y is equal to 1? So you ask yourself, in which case this happens? It happens in both cases. In two cases, sorry. If Y is 1 and X is 0, or if Y is 0 and X is 1. And what are the probabilities of these two combinations? We have 0.42 and we have 0.21. So we are saying that probability that x plus y is 1, it's equal to p of 1, 0 plus p of 0, 1. So we sum up their probabilities and we get 0.63. Now what about x plus y is 2? Let me first clean this up for you so you don't get confused. All right. Let's see again. So in which cases x plus y is 2? If y is 0 and x is 2, then this applies. So their sum will be 2, and this is their probability. Now, if x is 1 and y is 1 and x is 1, their sum will be equal to 2, and this is the probability. And if y is 2 and x is 0, their sum will be equal to 2, and this is the probability. So you can see here that we have 3 cases that lead to the sum being equal to 2, and therefore we sum up these 3 probabilities and we get 0.19. Now, in which case x plus y will be equal to 3? It's when y is 1 and x is 2, so the sum is 3, and we have a probability of 3% that this combination happens, or when y is 2 and x is 1, and the probability of this combination is 0.02. So the probability that x plus y is 3 is the sum of these two probabilities, and it's 0.05. Finally, what's the probability that the sum is equal to 4? This happens in only one case, where both x and y are equal to 2. And we can see in the bivariate probability distribution that this happened only in one case. Here we go. And this will be the probability that x plus y is equal to 4. And now we have a probability distribution of a completely new variable, which is x plus y. You can call it z, you can call it w, whatever you want. But you see, this is the importance of a bivariate probability distribution. We can derive a probability distribution of a third variable, a fourth variable that derive from these two original variables, x and y. Okay, one last thing about the bivariate probability distribution. We have seen in the previous slide that given a bivariate probability distribution of x and y, we could derive the probability distribution of their sum. And from that probability distribution, we could find the mean of x plus y and the variance of x plus y. But, you know, we did not have to find the probability distribution of x plus y to find the mean and the variance of the third variable x plus y. We could use also the laws of expected values and value and the variance. We have seen these laws whenever we have one variable x, and we, for example, e of x plus c, the constant c was equal to e of x plus c, right? And the variance of cx is c squared v of x. Okay, now this law applies when we have two variables, x and y, and it says that e of x plus y is the sum of the means of x and y. And the variance of x plus y, the new variable x plus y, is the sum of the variances, plus you have to add 2 times the covariance of x and y. However, if you are told that x and y are independent, so we know that their covariance will be equal to 0, which means this will become 0, and which means the variable of x plus y will be only the sum of the variances of x and y. Okay, so let's apply these laws in our Xavier and Yvette example. Again, we are given the bivariate probability distribution, and we want to find the mean and the variance of the sum of x and y. So remember from previous example 7.5, that we found the mean of x to be 0.7, mean of y 0.5. We found the variances and we found the covariance, all right, minus 0.15. So to find E of x plus y, that's very easy. We sum up the means of x and y and we get 1.2. Now to find the variance of x plus y, if you want to apply this formula, v of x plus v of y plus 2 covariance xy, so all what we do is to plug into the formula the values that we found before. So this is mu x, this is mu y, and this is their covariance. We multiply by 2 and we get 0.56. All right, so that's it.